Hello, this is Dr. Hanaa Assil, and this is paper 2C, June 2021 in the IGCSE Edexcel syllabus. Let us take a look at the questions and discuss the answers. So this was the first question, and he says using the periodic table, and you know that you will have a copy of the periodic table in front of you. Name the element with atomic number 14. Now, which element has atomic number 14? I'm going to remind you that atomic number is the small number. So which one has a small number 14? That is silicon. Name the element with a relative atomic mass of 11. Where is atomic mass 11? Mass is the big number. So the one with atomic number 11 is boron. Now he's saying name the element in group 2, period 3. Where is group 2, period 3? Again, remember that we count the periods starting from hydrogen and helium. So hydrogen and helium are in period 1, then lithium, beryllium, boron till neon, that's period 2. So the one in group 2, period 3 is magnesium. And please, when he says name, write the name. In some cases, he will accept the symbol, but keep in mind that if he's asking for name, give him the name. Determine the number of neutrons in a phosphorus atom with mass number 31. Again, in order to determine the number of neutrons, you have to look at the periodic table, look at the atomic number, because the mass number is protons plus neutrons. So if he wants neutrons, he will have to subtract the number of protons, which is the small number. So the number of neutrons will be the big one minus the small one. That is 16 neutrons in phosphorus. State the electronic configuration of an aluminium atom. Remember, electronic configuration means arrangement of electrons. So I need to know how many electrons in aluminium. Where is aluminium? The small number is 13, so that means it has 13 electrons. The first shell takes 2, and then the second one takes up to 8. So the electronic configuration for 13 electrons is 2, 8, 3. State why neon is unreactive. Remember, neon is in group 8 or group 0, and we said all of those in group 0 are unreactive because it has a full outer shell of electrons. A student investigates the rusting of iron. She places an iron nail in a test tube of water and leaves it for several days. Predict the appearance of the iron nail after several days. Of course, after several days, the nail has rusted. So what is the appearance of rust? It is a reddish brown flaky coating on the iron. Name the main compound in rust. What is the compound in rust? We call it hydrated iron 3 oxide. Remember, iron needs water and oxygen, so it becomes oxidized and hydrated, so it's hydrated iron 3 oxide. The student then sets up 2 more test tubes containing iron nails. So you can see in tube 1, he has boiled water covered with oil. In tube 2, he has a drying agent and there is no water. Explain why the iron nail in tube 1 and the iron nail in tube 2 do not rust. Now, why do these nails not rust? Of course, the one in tube 1 doesn't have what? It has water, but the boiled water means that the oxygen that was dissolved in the water has been removed, and the coating of oil prevents any more oxygen dissolving, and that means tube 1 has no oxygen. So the boiled water has no oxygen, and this is needed for rusting. Now, tube 2, why isn't the nail rusting? Well, because the drying agent absorbs the water. That means the nail doesn't have any water, and this is needed for rusting. The diagram shows the industrial equipment used to separate crude oil into fractions. Give the name of this equipment. We use what to separate the crude oil into fractions? We use a fractionating column. Give one use of the fuel oil. Remember we said these fractions that come out from the fractionating column, you need to know their order and you need to know their uses. So he says one use of fuel oil. You should know this is fuel for ships. Give the names of fractions A and F. What is fraction A? Fraction A is the very first one on top. That is the refinery gas. And fraction F is the last fraction in the fractionating column, and that is butane. Then he says one compound in the gasoline fraction is the alkane octane, C8H18, and one compound in the kerosene fraction is the alkane dodecane, which is C12H26. Now, these two alkanes are covalently bonded and they have simple molecular structures. Give the general formula for alkanes. Remember that we said you have to know general formula for alkane and for alkene. The one for alkane is what? CnH2n plus 2. CnH2n plus 2. That means the hydrogens are twice the carbons plus 2. Okay? Explain in terms of their structures why C12H26 has a higher boiling point than C8H18. Remember, all of these, he says, and we should know, they have simple molecular structures. And we said normally simple molecular structures have low boiling point and melting point. And if we say why, it is because they have weak attraction forces between molecules. Now he's saying C12 will have higher boiling point than C8. Why do you think is that? Then that must mean that the attraction forces between the molecules in the C12 are stronger than those in the C8. So we should know that for larger molecules, so C12H26 is a larger molecule, more carbons, more hydrogens, more electrons, the attraction forces between the molecules are stronger than a smaller molecule, so they will need more energy to be broken. Okay, so if we have a small molecule, there is weak attraction forces between the molecules. If we have a larger molecule, then there is still weak attraction forces between the molecules, but now it is stronger than the ones between the smaller molecules. Catalytic cracking can be used to convert the alkane C12H26 into more useful products. First of all, give the name of the catalyst used for catalytic cracking. You should know the catalyst for cracking, we said, is aluminium oxide, or it could be called alumina, or there is another one which we call silica or silicon dioxide. You can remember one of them, that's fine. Complete the equation for this cracking reaction. Remember we said in cracking, the number of carbons and hydrogens on both sides of the arrow should be the same. So if I'm starting with C12 before the arrow and I'm removing C9, then I'm left with how many carbons? Well, I'm left with 3 carbons. Then I'm starting with H26. I removed from it H20, so I'm left with H6. So the missing molecule is the rest of the carbons and the rest of the hydrogen. So that is C3H6. Question 4 says a student investigates the solubility of potassium nitrate in water. She measures the masses of potassium nitrate that dissolve in 25 centimeter cubed of water at different temperatures. The table shows the student's results. One of the results is anomalous. Remember we said anomalous means it is wrong, means it is away from the curve, means we do not include it when we draw the curve. Okay, first of all, he says plot the results, then draw a circle around the anomalous result, and then ignoring the anomalous result, draw a curve of best fit. So if you plot these points on the curve, they look like this. Again, I'm reminding you, we use small x's or dot with circle to plot the points. Now, obviously, there is one that's away from the curve. So he said put a circle around that anomalous one. So when we draw the curve, we do not include that point. We need a smooth curve. If there is the anomalous result away from the curve, we just ignore it. So this is the curve he's looking for. Then he says, suggest two possible mistakes that could have caused the anomalous result. Why do you think he got a result that is below what he should get? Can you see that the anomalous result is below what he should have gotten? Yeah, for 50 degrees Celsius, he should have recorded 20 grams. He recorded less than that. He recorded around 17 or 18 grams. So why do you think he recorded something lower? That may be due to the fact that he did not stir the solution, or that when he measured the solubility, the temperature was not 50, it was less than 50, or the volume of water was not what it was for the others, which was 25 centimeter cube. Then use your graph to find the maximum mass of potassium nitrate that dissolves in the 25 centimeter cube of water at 75 degrees Celsius. So this is the graph we have. Remember, this is a graph of how much dissolved in 25 centimeter cube of water. Now he's saying at 75, how much do you think will dissolve? Well, I need to extend the graph, and then from 75, I go up to the graph, and I find that I will need to dissolve 39 grams. Use your graph to calculate the solubility of potassium nitrate in grams per 100 grams of water. Again, if we remember, he was doing all of this dissolved in 25 centimeters. Now he's looking at 25 degrees Celsius, so I go up from 25 degrees Celsius and I find that at 25 degrees Celsius, I have 11 grams dissolved in 25. And remember, 25 centimeter cube is the same as 25 grams. So that means 11 grams dissolved in 25 grams. So how much dissolves in 100? So a simple cross multiplication would give you 44 grams. Ethanol, C2H5OH, is a member of a homologous series of alcohols. Give two characteristics of a homologous series. Again, I'm going to remind you, what do we mean by homologous series? We said homologous series is a group of organic compounds. So we have a group called alkanes, another one alkene, another one alcohol, and so on. Each of these is called the homologous series. Now, all the members of the same homologous series have the same what? What are the characteristics of a homologous series? We said all the members of the same homologous series would have the same functional group, same general formula. If you want a third one, then you say same chemical properties or similar chemical properties. When ethanol is heated with potassium dichromate and one other reagent, the ethanol is oxidized to ethanoic acid. So he's trying to oxidize ethanol to ethanoic acid. We should add potassium dichromate and what? Potassium dichromate and sulfuric acid. And please, he's saying give the formula, so you have to write the formula. So remember, to oxidize an alcohol to an acid, what do we add? We can add potassium dichromate and sulfuric acid, or also we could add potassium permanganate and sulfuric acid. Now the color change when we use potassium dichromate is orange to green. Draw the displayed formula for ethanol and ethanoic acid. Remember, displayed formula means all the bonds with all the atoms showing. So ethanol, remember the word eth means two carbons. All means on one of them you have an OH. So this is the displayed formula of ethanol. Ethanoic acid, eth also has two carbons, but the acid now has C double bond O, single bond OH. Okay, please learn these things if you still don't know them. Ethanol can be manufactured by two different methods. The table gives some information about the two methods. Discuss the advantages and disadvantages of these two methods using information from the table. Okay, what were the advantages and disadvantages of each method? So if we look at hydration of ethene, we said it produces pure product, so that's an advantage. It is a fast reaction, that's another advantage. But the disadvantage is it needs crude oil because this is where we get ethene from, and crude oil is a non-renewable resource. It also requires high pressure and high temperature, so it is more expensive. So that's hydration of ethene. What about fermentation of glucose? Well, you should realize that glucose is obtained from sugar cane. This is a renewable resource, so that's an advantage. It works at room temperature and pressure, so it is less expensive. You don't need to use a lot of energy. But then it is a slow process and the product is not pure, so you need to purify it. Okay? Please remember these two methods of making ethanol. The word equation for fermentation is this: complete the chemical equation. So of course he says, and you should know, it gives ethanol and carbon dioxide, and the balancing will need 2 and 2. The diagram shows how hydrogen gas and chlorine gas can be prepared in the laboratory by electrolysis of a concentrated solution of sodium chloride. Give a test for hydrogen gas. What was the test for hydrogen gas? Please remember the tests. They will come in both papers. Hydrogen, of course, we said what? Insert a lighted splint, it pops. What was the test for chlorine gas? Insert damp blue litmus paper, it bleaches. Okay? The ionic half equation for the formation of chlorine at the positive electrode is this. State why this reaction is an oxidation reaction. Why do we say that this is oxidation? Because the chloride ions lost electrons. Remember, loss of electrons is oxidation. Remember again, there is no gain or loss of oxygen in this equation, so you cannot mention oxygen. Give the ionic half equation for the formation of hydrogen at the negative electrode. Remember, hydrogen, I have in the solution, I have H+. So H+ takes electrons or gains electrons and becomes hydrogen gas, and do not forget to balance. State why it is safer to do this electrolysis in a fume cupboard. Remember, once he mentions a fume cupboard, then there must be gases somewhere that are poisonous or toxic. So actually the chlorine gas that is formed in this reaction is poisonous or toxic. So you should do this experiment in a fume cup. Suggest why the volume of chlorine collected during this electrolysis is less than the volume of hydrogen collected. From the equation, they should be the same. Always remember, when we're collecting chlorine over water, we usually collect a volume that is less than what it should be. Why? Chlorine dissolves in water. So some of the chlorine that was produced dissolved in the solution. That's why what we collected is less than what it should be. In the chemical industry, chlorine can be produced by the electrolysis of molten sodium chloride. Explain why sodium chloride needs to be molten rather than solid for electrolysis to occur. Again, we said what? Sodium chloride is ionic, so sodium chloride, the ions are free to move when molten, but not when solid. Calculate the maximum volume in decimeter cubed of chlorine gas that can be obtained from 23.4 tons of molten sodium chloride. So this is the equation. We're starting with sodium chloride and we're trying to collect chlorine gas. Now we're starting with 23.4 tons. Remember that the equations for number of moles all need grams, not tons. So when we try to calculate number of moles of sodium chloride, mass over molecular mass, I need to change the 23.4 tons to grams. That is 23.4 times 10 to the 6 over the MR of sodium chloride. That gives me 4 times 10 to the 5 moles. Then I look at the equation. He's asking about chlorine. What is the number of moles of chlorine compared to that of NaCl? You can see that it is half of it. So the number of moles of chlorine would be half of what we calculated. That will be 2 times 10 to the 5 moles. Now I can calculate volume. How do I get volume of a gas? Number of moles times 24. So that comes out to be 4.8 times 10 to the 6 decimeter cubed. Please note, is he asking for it in decimeter cubed or centimeter cubed? He's asking for it in decimeter cubed, so that's my answer. A student does a titration to find the concentration of a solution of phosphoric acid. He uses these pieces of apparatus, X, Y, and Z, in his titration. Give the names of X, Y, and Z. Of course, what is X? Conical flask. Y? Pipette. And Z is a burette. What is the color of phenolphthalein in acid? Do you remember the colors of phenolphthalein? You should. Phenolphthalein in acid is colorless. In base, it is pink. Then he has a table of the student's results when he did the titration, and he's saying concordant results are those within 0.2 centimeter cubed of each other. Add ticks in the table to show the concordant results. So we said when we do titration, and we repeat several times, we choose the ones that have results within 0.2 of each other. So more or less by 0.2, not more than that. So which of these are concordant? 30.35, 30.25, and 30.30. All of these are within 0.2. But the 30.0 is very far away from it. So we're not going to include it when we calculate the average. Of course, calculating the average will be the addition of all the concordant results divided by their numbers. So we have 3 of them. So that means that the volume of sodium hydroxide I'm going to use in my calculations is 30.30. Remember, when things are in 2 decimals, then your answer should also be in 2 decimals. Table 2 shows the titration results of another student. So he has the volume of phosphoric acid is 25, concentration of sodium hydroxide, volume of sodium hydroxide, and he gives me the equation. And he says, calculate the number of moles of sodium hydroxide. So how do I get number of moles of sodium hydroxide in a solution? Number of moles is concentration times volume. I have the concentration of sodium hydroxide. The volume in centimeter cubed, you have to divide by 1,000. So this gives me the number of moles of sodium hydroxide. Then he's saying, calculate the number of moles of phosphoric acid. So I look at the equation. Obviously, the number of moles of phosphoric acid are 1/3. So if I have a certain number of sodium hydroxide, I divide it by 3 to get the number of moles of phosphoric acid. Now he wants the concentration of phosphoric acid. Well, concentration is number of moles over volume. So the number of moles that I just calculated over the volume that he gives me, which is 25, and this gives the concentration of phosphoric acid. And that's the end of the paper. I hope you understood all of this, and I hope this was helpful to you. Thank you for listening.